Welcome to the video. Today we're going to be doing vulnerability assessments and practicing that skill. So how do we actually get practice doing vulnerability assessments, scanning and whatnot? The best way to do that is to do it on a live target. So there's a few ways you can do that. Really, the number one way I would recommend that you do that is have your Kali machine connected to the network at your house, do a scan of your entire house, and then pick a machine on there, and then do some more nmap scanning, maybe use Nessus or OpenVAS to do some scanning on those particular machines. Those are yours, so it's totally fine. Go for it. If it's not your machine, you do need to ask permission before doing scans on it. Okay. Additionally, you can actually download machines onto your host machine and do scans that way. In this video, I'm not going to be showing you scanning my own home network. I've done that in previous videos. In this one, we're going to be setting up an intentionally exploitable machine. It's called Metasploitable. Now, there's a lot of videos on how to exploit Metasploitable. You can use Metasploit on it. But we can use it for learning other things too. And today we're going to be using it to learn vulnerability scanning and sort of the process of using nmap to find services and to detect vulnerabilities. All right, let's dig right in. Now on my screen, I have my VirtualBox, and I'm going to go and set up Metasploitable on this machine. Now, I did download this machine, and you do need to go to their website. And I'm going to show on the screen right here. You can see this is where you actually get the Metasploitable. Don't go to SourceForge. Go right to Rapid7. Go right to the source. That's the people. Those are the people that they want you download the real version. Okay. I have had people download the incorrect version, and then their antivirus went berserk on them. So avoid that challenge. I'll show you what the file looks like. When you get your Metasploitable downloaded and you unzip it, you'll be presented with this. Now, if VirtualBox is your default solution, then you can just double click on the .vmx. What I'm going to do actually is I'm going to create a machine and then take the VMDK file and make a Metasploitable machine with that. So let's go ahead and do that process. Machine, new. And I'm going to give it a name. And it's a Linux machine, so let's pick Linux. And really, if we go to Debian, then we should be fine. I'm going to hit next. This is a very low resource heavy machine. Like it takes almost nothing. You could have one CPU, it's totally fine. And honestly, 2 gigs of memory is plenty for Metasploitable to run successfully. So we're going to do next. On this screen, we're actually going to be navigating to an existing virtual hard disk. Remember that .vmdk? So let's go and locate the file that we want and add. I'm going to navigate to my downloads where I currently have it. Metasploitable. And look at that. The only one that's available is the .vmdk. So I like that. And we're going to choose that one. So it's got 1.79. Great. Choose. We're going to hit next. And we're going to hit finish. But we're not ready yet because I want to create a networking environment that is conducive to the type of scans I want to do. We could put this as a bridged machine. But what that means is that it is actually touching, or it's on the same network as everything else in my house. You got to decide if that's okay with you, right? It is a intentionally vulnerable machine, so somebody could potentially attack it and then have it as a pivot point. But really mitigate your own risk on that one. Today, I'm going to be actually setting it up in a host-only environment so that I've got my Kali machine and I got my Metasploitable machine, and they can only talk to each other. Okay, and that's all they can do. Let's go and double check to make sure that my two machines are on the exact same network. First, let's double check that my host only Ethernet adapter is configured correctly. So on my VirtualBox, I've got 4 various needs. They've got their own network here. Let's go ahead and choose, for me, host only Ethernet adapter 2. And you can see that I've got a network over here, and the DHCP is enabled. You do need to have that turned on, because when we put our Metasploitable into this network, it's going to ask the DHCP server for an IP address. That's important because we're not going to go in there and set it, the IP address ourselves. We could do that, but that's more work than what we need to for this exercise. So make sure that's enabled. You can make sure it's enabled by navigating down here to the DHCP server and clicking on Enable Server. Over here you can configure the DHCP pool here. So the lower, where does it start? The upper bound, where does that pool end? And then setting up the server address. Great. I want that, so I'm okay with that. I'm happy. Let's go and make sure that Meta, the machine that I just made, in fact has that configuration. So settings, fly on down to network, and by default it starts with NAT, which is fine if I wanted that, but I don't. So we're going to choose host only adapter, and I'm going to choose the adapter that I want. Remember, I wanted number 2, and so number 2 is right there. Great. Let's hit OK, and at this point we could start the machine. Awesome. If you've got the screen looking like this, you know that it works. So we could log into this machine and get its IP address right now. That's completely fine. But why don't we do something else? Let's do a little bit of host discovery once we get Kali Linux onto the exact same network. So I'm going to shrink this and then go into my Kali machine and configure its networking. So Kali settings, go to network, and let's make sure that we're on the same network as the Metasploitable. Host only adapter, and I'm going to choose number 2. Remember, that's the same one. It's got to be the same one. They're not going to talk to each other if they're not on the same one. Now my Kali has DHCP enabled already, so it's going to ask for an IP address as soon as it's on a new network. Okay, that looks good. Let's power that machine on. My Kali is now turned on. Let's check out the IP address, see what we've got. Beautiful. I'm in the correct network. So let's do a little bit of host discovery to find the IP address of our Metasploitable machine. There's a variety of ways to do that. I see a lot of videos that choose to use NetDiscover as their first choice. So let's do it. And really what it's going to do is send out ARP addresses to the network. And so we know that this is our server address. Let's take a peek at our address again. We're .5, and we've got a response from a .6. And so really there's 3 machines on this network: Kali, Metasploitable, and our server. So we know now that our target machine is this machine here. So copy that. I always like to do a ping first. Uh-oh. 168. That's 164.5. All right. That's my network. And 6 was our number. Let's give that a big old ping. Bingo bango, we're receiving some ICMP packets from our target machine. Now, we've confirmed that we can reach the Metasploitable. let's do a really quick test to confirm that it is that metasploitable machine. And now it's really simple. Let's do it. nmap ss t4. I always throw t4 on there. 192.168.164.6. This is, I'm just gonna quickly blast it and we'll see what it comes back with. It should come back with lots of stuff. Yeah, we've got oodles of things. So every single one of these ports has a vulnerability on it, and we're going to be going through scanning some of these ports. All right, on to the next step. Before we get too deep into vulnerability scanning with nmap, we should chat a little bit about what is the purpose of a vulnerability scan. So it's different than a pen test, where in a pen test you're going to be actually finding the service, researching its vulnerability, and then exploiting that vulnerability to gain access and prove that there is a weakness so that the client can then patch that weakness and make their system stronger. Boom, that's a pen test. Vulnerability assessment doesn't go as far as actually exploiting. It finds a vulnerability, documents that vulnerability, so that the client can then make the educated choice of, do we fix this or do we not fix this? What is our risk appetite for the existing risk to our systems? I'm going to show you a couple techniques where we can do scanning on the entire system. Now, keep in mind that a computer has 65,000 plus logical ports to scan that, or could have a server running on it or utilizing it. And in this case, we don't have 65,000 documented. So we only scanned a small number of them. What we would want to do is actually do a fairly deep, verbose scan on all of the ports. Now this is going to take time because remember there's 65,000 of those things. So you're going to have to really plan out your engagement with that properly. The reason for that being is that not every network is made the same. You could have a network with 5 devices. You could have a network with 150 devices. And if you're going to do a port scan of all 65,000 ports on every single asset, you can see right there that the amount of time to complete that task is going to get a lot longer. Right now, I'm actually going to show you how to do a port scan on all the ports. It's pretty straightforward, and we'll do a time. We'll time it to see how long it takes. Again, we're going to do the stealth plus a time interval of 4, the IP address, but what we're going to do here is I'm actually going to throw in a -p-. Pretty straightforward. It's going to scan all of the ports. All right, let's do it. There you go. So it took 18 seconds, pretty fast, but remember that I've got only 3 assets on the on this network: Kali, Metasploitable, the server, and there's no interruptions between anything else inside my house to interfere with that network. And if we look, we actually did get some more ports. So these ones here, if I remember correctly, weren't in the previous scan. So there is value in actually doing or including all of the ports when you do a network scan. Now, really good practice for vulnerability assessment would be to save your scans. I haven't done that yet, but I'm going to show you right now. Let's do a make directory, and we'll call it demo. I'm going to cd to demo. There's nothing in there. Makes sense. Let's do that exact same scan that I did previously. But this time, we're going to save the output to the same style that we saw on the screen. And I think it's best practice to give it, that output file, a logical name. If I'm scanning to get all of the ports, say it, all ports. And even better, maybe even give a little hint on what kind of scan that you did. Because if it's a stealth or a TCP connect, it's going to be a little bit different. If it's a UDP, it's going to be different. If it's a Christmas, if it's a push, if it's a whatever, so script scan, it's going to be a little bit different. So do yourself a favor, make your outputs make sense. Let's do it. Exact same scan. Now we're putting all that content into a output file. Beautiful. Looks the same as before, doesn't it? Now we can see our file is there. I'm going to open it up. Bingo bango. There's the file that we just made, and now I've got it saved. Okay. Let's take a peek at a couple of the services. Whenever I'm doing a vulnerability scan, or a vulnerability assessment rather, I will land and check some things first. So for example, things that jump out right away are anything that is any service that allows remote control. So you have Telnet would be one. RPC bind potentially can have one. Login obviously is going to. Shell will have one. NFS maybe. We'll have to dig into that deeper. VNC for sure. Definitely will have some. And then these guys, we don't know what those ones are yet. But that's okay. We know they're there and they're listening. So that's what's important. So I would poke at those ones first. Other one that I always enjoy investigating as well. Oh, SSH as well. My bad. FTP. I love FTP. I think it's a fascinating service. It is incredibly useful when used appropriately, but it also is incredibly dangerous if you don't use it appropriately. So I always poke at that one first. You'll see FTP. If you see this on a workstation for somebody, then that's a little weird. There should be a business justification for having an FTP turned on. You will see this quite often on printers, though. And then whenever I have a conversation with a client, I'll ask them, "Oh, your printer is a vulnerability just in itself because it sits there and the IP address never changes." And typically, when you set up a printer, it exists, and if it functions, then the users are just happy that it works. But a bad actor could potentially sit resident on that printer and then just be watching the entire thing. Go on Showdown for a moment and look up popular printer brands, and you'll see that they're public facing. You turned on, and many printers have Telnet turned on as well. And some of those assets actually can't have these features turned off because all assets are of different varieties. They could be super old, they could be brand new, and typically if it functions in an environment, the client is just happy that it functions. I want to poke around at FTP first because it's kind of like a good starting point for vulnerability assessments. But what you should also see is if I wanted to do an aggressive or an all scan on a target, you could do a scan similar to this. You would do with a -A, and you're going to scan all the ports, and you're going to give it a good file name. And it's gonna do everything that nmap can do. There's a challenge though. So remember there was 18 seconds for the last one. Let's do it again. Still gonna be fairly short, but keep in mind that this is just one machine on a very low impact network. All right, let's do it. This is what it's like doing the aggressive or all switch on an nmap scan. Hopefully you've got a coffee because you're going to be sitting around waiting for it. I honestly think that there's valid usage for the switch here, but as you get practice with nmap, there's so many different like nmap scripting engine scripts, intentional ones, ways to optimize nmap they can make your scanning so much faster. Right now we're gonna sit around twiddling our thumbs, but this is kind of like a proof of point here. 158.96 seconds. What is that in minutes? 2.63 minutes. Doesn't seem like much, does it? And we got a whole schwack load of information. All good, valid information for helping us determine vulnerability. And truth be told, I think we're actually short on some of the information that we could actually have here. I don't like using that, the -A. It has a purpose. If you're in a pen test, you would never use it because it's incredibly noisy and it's smashing the target with the whole grab bag of tricks that nmap has. Let's go back and we're gonna particularly probe into the FTP service. So now here's a really good tip to make your life easier. Take notes. And it doesn't sound like fancy advice, but really there's a ton of scans available to do through nmap onto your target. Document those so that the next time you encounter a open FTP or an open telnet, you'll have documented the kind of scans that you would use for that particular vulnerability or service. All right, let's dig into FTP. So now, a really popular scan that I like to do for every single port that I'm testing to see for vulnerabilities is a default script scan. So let's do SV, SC, port 21. And in this one, we're doing a script scan. So that's what the SC is. And the script scan needs to have the versioning also included because it's going to be checking its databases that it has, nmap, and it's going to be saying, oh, there's a FTP version this. Do we have any existing vulnerabilities documented here? Let's check it. Let's check. And we're going to be specific this time. Port 21, and we got our target. Bingo bango. Now, important things to make note of when we are looking at finding a vulnerability. Document the version. If we have a version, that gives us something to research. Okay, so I would write this down right away, and in a moment here, we're actually going to open up CVE details and actually throw this in there to see if there's any documented vulnerabilities for there. There's a lot. I would document the version, and I would document the fact that I have an anonymous here. Now, you will find services that have anonymous login. SMB would be one. Various other NFS services will just allow you to connect. We're doing a vulnerability assessment, not a pen test. And I've said that before, but it's also important to keep remembering that because if you're doing a vulnerability assessment, you're not going to do things like a brute force attack. You are not going to try and break into the system, right? Getting information on this is enough information to be able to provide your client with details that say, hold on here, you potentially have an issue. You can take that and be like, you have an issue here, potentially. Do you want me to validate that somebody could take advantage of that? Would you like me to exploit that? That would be a decision for the client to make. Because at that point, the kind of engagement that you're doing is changing. Okay? And you don't want to accidentally do pen test type activities on your client if they're not wanting you to do it. You can get in some big trouble. Okay, let's go and do some research on VSFTPD 2.3.4. 2.3.4. Search, and it's going to come back with loads of stuff. So you're as a security professional, you do need to go through this and read the content that you have available to you. So let's click on the very first one. So it's got a CVSS score of 10, so it's pretty horrible. And what you want to do is that if you see things like this, you know the version, go into CVE details and try to make a connection. And if you can make a connection, then that's something that you can provide to the client and say, whoa, there's something bad here. And this number means something. It's significant. Download between this contains a backdoor which opens a shell on port 6200. Okay. The confidentiality impact, and this part here, I really like this over here as well, because it talks about some of those main things of security. We've got confidentiality, integrity, availability, and then we get the extra flavor of access and authentication. And is there an impact? It's complete, like it's red. Integrity, boom, yeah, there's total compromise of system integrity. And this is something I would actually copy and paste in my report to a client. Okay, because this is legit. In your report, you'll also include your opinion on how does this connect into your client's environment. How do we see this service existing? Like, is it on a real server? Is this on just some user's machine? Like, there's considerations that have to be made depending on where this service lives. And then it's always great to give mitigation strategies, right? For this one, it would be, if FTP needs to live on that machine, switch to a different FTP service. That would be one mitigation. Another one would be completely update this FTP service. That's another one. Another recommendation would be audit the configuration on an updated FTP to make sure that it is meeting best practices for industry. Okay, so there's 3 mitigation strategies. Oh, fourth one, remove it entirely. If it is not a service that's needed, see you later. So all that's good information. Now, notice we've just used nmap and a little bit of digging to gather information that we can use to provide to our client. We didn't have to use Nessus or OpenVAS or anything else. nmap was literally a sufficient tool to get the job done. We talked about FTP, and now really there's a couple other things that we can do for digging into other services. And this one I like. I do this often. Let's go to nmap.org and we'll search for SSH. And what's going to come back with is various NSE scripts. So these are nmap scripting engines. These are things that are made to do some various tasks. Now you've got to be careful because some of these are themed as a more offensive. So you can see right away that the first one is called SSH brute. We're doing a vulnerability assessment. We're not doing a pen test, so we're not trying to brute anything. You can always check with your client if they're okay with that, but there could be implications. Go in here and, honest to goodness, this is such a great resource. I'll just pick this one, SSH authentication method. So what are the authentication methods being used by SSH? And then it gives you a method to test it out. Let's actually run this script on our Metasploitable. Let's see what it comes back with. Clear nmap port 22 script SSH I want root, and we're going to get an IP address of our target 192.168.164.6. So let's chat about this line here. We're choosing port 22. We're going to activate the script functionality of nmap. We're going to specifically choose this script called SSH authentication methods. The argument that's required is user. I want to see what comes back when I fire root at it. Enter. Oftentimes with these vulnerabilities is that on their own, the vulnerability isn't necessarily bad. What becomes a challenge is that when you package up all of the vulnerabilities, they get a better picture for the attacker and become something that can actually be used to exploit the system. Okay. From this, can we tell if the system is brute forceable? Not really. One would have to try to authenticate multiple times to see if you get shut out. You will also be able to tell if you try to log in multiple times if there's IP banning, right? But then again, you have to decide if trying to authenticate is crossing the line of that rules of engagement, because technically you are connecting to a service. You're going just a little bit further than determining a vulnerability. There's a bit of a line there. All right. So use nmap website to test out different scripts. There's so many. Like, it's such a good resource. I want to go back to this scan here, but I would like to look at this port here. It doesn't really tell me anything. So in nmap, when we send we're using TCP and we send a SYN packet or whatever flag to a target port, it comes back and nmap will tell you if it's open. But when it did its version determining, it sometimes doesn't know, and that's okay. In this particular case, we don't know what it is, so we have to dig a little bit deeper. So the port specifically I want to poke at is 50,622. So off the top of my head, I don't know what that port is, but we can ask the internet. What is 50 used for? Let's do that. Used for. Speed guide sometimes has some good stuff. Gotta take it with a grain of salt. Give it a read. But let's actually scan that port. So while I may not have found the information on this website or the other website, that's okay, because I'm researching to figure out, is there a common service that would be associated with that port? Yeah, that's part of the process. And I would document it. If I see some correlating information, then I'd bring it in there. Let's scan that port. And notice I'm going to go with my default script scanning here. 5622. All right. So some more information. So it's nmap is saying that it is this service. We can copy that and research it. What is nlock manager? We're seeing some NFS stuff. We can also see that we've got version of RPC, which is 1 to 4. The 1 in itself is telling us that's an older version, which is not a good thing. And for as far as a vulnerability assessment goes, that is sufficient, because what that does is that can trigger the admin to actually go in and look up why is this port on and why is it listening consistently. And your recommendation could be audit that port, figure out if it has a purpose, and if it is not a business relevant port, then completely turn it off. Or package this machine behind a different firewall or segment it into a network, whatever makes sense for your client. So there you go. I am not going to go through all of these different things, but the point of this exercise is that I'm going to be doing some of the similar tasks to go through all of these different things. Okay, similar process for every single port. It's going to determine potential vulnerabilities on the system. Some of these services may have multiple vulnerabilities, so it just takes a little bit of research. All right, thanks for watching. A little bit of a longer video, I know, but I appreciate that you made it to the end. A couple other videos on the screen that I think that you're going to enjoy, and talk to you soon. See ya.